Hello everyone, this is going to be our last lecture with simply linked lists, and we're going to look at simple searching in it. So far we have looked at how to insert and remove nodes in a linked list. Now we're going to look at how to search for a node. Now keep in mind this is searching for a node, so it's going to be just a simple return of true or false. If I search for a node and it's there based on its key, it's going to return true. Otherwise, it's going to return false. Now, looking at it from this point of view, we're going to keep it simple, and we're going to look at just two methods. The first one uses recursion, and the second one uses really simple traversal. Let's start with the recursive one. So this is the recursive searching, and we're going to define a method called recursive search. Now, what is this method going to receive from us as users? Well, it's going to receive, it needs three things, but it's going to receive two. Why? Because self is not something that we're going to give. It already have it, and we're going to send a node and the key that we're looking for. Now, what does that mean? If we look here, we're going to see that this is a very simple linked list that we've been working for the past few examples. And what I want in here is to give a node. And normally what I'm going to give is the first node, it's the head. And I'm going to jump and look for a key. So let's say that I'm looking for this number 4 in here. So I'm going to give the first location. I'm going to give the node of the head, starting at the first location, and check the data, and jump and check, and jump and check, all the way until I reach a node with that date where the data is equal to the key that I sent, or until I reach the end. And I don't mean this node in here, but I mean this location in here, because when I jump from this node to here, it's going to jump to next. This node's next is none because there is nothing after it, and it's going to jump to none. So I'm going to stop when I either find the key, which is equal to one of the datas for my nodes, or when I reach the end in here, which is none. And this is exactly what I'm looking for, or exactly what I'm checking for. I'm going to say if, let's check for if it reached the end. I'm going to say if node is equal to none, which means I jumped through all of my linked list but didn't find the key, didn't find any node, with the data equal to the key. And I'm going to return false, because that means that the number that I gave, the key that I gave, is not in my linked list. It's not in there. So I'm going to return false. Well, what if we did find it? I'm going to ask the next question. If node.data is equal to the key, then return true. So what's happening in here? I'm asking, did I reach the end of the node without finding it? If that condition is real, if it's actually applicable here, that means I reached the end, and that means I didn't find the key, so return false. If this condition is not going to work, then this is not going to work. I'm going to jump to the next one and ask, is it equal to my key? Now, let's say that I'm looking for number 4. Key is equal to 4. What I'm going to do in here is send the first node, which is the head node, in here, and send number 4. So right now I'm here, and I'm asking, is this equal to none? Is this none? No, it isn't. This is something. This is a node. So it's going to leave this and jump to the next if statement. Is the data, node.data, this 0, is it equal to 4, the number that I sent? And again, no, it isn't. So this is not going to work as well. Okay, then what am I going to do? Well, it's very simple. I'm going to call, this is the recursive part. I'm going to call my function, my method that I just created on itself. And I'm going to return self.recursive search. And it's the same one, it's the same name in here. And I'm going to send not node, because I just checked it, but I'm going to say node.next. And the same key. And what this is going to create, if we go back to our example where key is equal to 4, and I start at the beginning and then say, is this none? Is this empty? No, it isn't. Okay, is the data equal to 4? No, it isn't. Call the same function with node.next and the same key and number 4. Again, is this empty? No. Is this equal to 4? No. Call it on its next. Call it on its next. Call it here where number is actually 4. So it's asking, is this empty? No, it isn't. Is the node.data, is this data equal to number 4? Yes, it is. Return true, and whenever a return happens, that means the function or the method is going to stop. So this is not going to work anymore, and that's it. Okay, let's check that with our within our code. So as we can see in here right now, we have, if I actually want to show you, so this is the last results that we got after the insertion and the deletion. So our linked list, based on the information that we are giving it right now, our linked list is inserting some things, and actually we're deleting the first item, so the 0 in here is done. What I want to do is, actually let me print. This is just to make it more acceptable from a GUI point of view. And then I'm going to print again, but this time I'm going to call list.recursive search, and I'm going to give it. It requires two things from me based on, because I'm not going to give itself. So node, I'm going to give list.head, and I'm going to search for number 4. Okay, and close. Now, why did I put it inside of a print? Because this method is returning something. I'm returning false and true. I'm returning a boolean. So you either put that in a print or you put the return values inside of a variable. You need to keep whatever that is returned. And let's check it. Hopefully there are no mistakes. And you can see 99, okay, and it is true. So it did find number 4. What if we search for number 1, which is not in our linked list in here, as you can see, and hopefully it will return false. Even if we look for 0, and remember that right now 0 is deleted, so it is not within our linked list, this is going to return false. So that was the recursive search. Well, we can make this even simpler by using a normal traversal search. Now, with the main thing with recursive search that annoys me personally is using a node, is using the head, because that is not 100% correct, especially if you're working with big programs. You want to give as little control to the program as possible. So what we are going to do in here is simple traversal search. And what I'm going to do is define traverse search, which is the next function. This one is going to take, sorry, not function, I keep on saying function, but it's a method because it's inside of a class. So traverse search is going to take self and just a key, no node. And what I'm going to do in here is just do a normal traverse. By the way, we did do the same thing here. This is the traverse that we are doing right now. And when you look at our codes, you're going to realize that they are being copied and pasted. So this code in here, which removes the first element, is actually the first code, or the same code in here, which deletes the first element. So it's very simple. I'm going to do the same here. It's just a normal traverse. So temporary equals self.head, because I want to start at the first location. And again, traverse is starting at the beginning and going all the way until the end. And this is traverse search, so I'm going to start at the beginning and ask each node if it has that item or that key that I'm looking for. So it's going to be while temp is not equal to none. What I want to do in here is if temp.data equals the key that we sent, equals the key that we sent, then what I want to do is print. I'm going to, let me print something in here. It's true or false. Just using true and false is not as enthusiastic as some of you might want. So let's print something very simple, like the key key is found, rejoice, which means become happy, and we're going to return true. And I'm going to ask you something. Do I need to put an else in here? Well, the answer is no. I can do the following. Look, after returning, I'm going to do this. And look at the spaces in here. Temp equals temp.next. Okay, so look at the space. This space, which means the if and the temp, both of them are within the while. So it's like I opened and closed. But what is happening right now is the following. I'm saying if I start at the beginning, okay, temp equals self.head, I'm here. While temp is none, it is not none, it is not empty right now. If temp.data equals the key, right now, is this equal to the key? If it is, let's say that I searched for 0 and 0 is the first item. So what's going to happen is I'm going to print this and return true. I found it. When the return is executed, that is going to stop all of the method, all of the function, and return control back to me. Okay, so everything after that's not going to be executed. But if that didn't happen, that means it's going to jump to the next line. And this is exactly what we have in here. It says, are you empty? No. Is your data equal to the key? If it is yes, then stop. If it's no, then continue. And jump temp equal temp.next. Jump to the next node and ask the same question. Now, when we look at it from this point of view, we're going to see that from a user's point of view, or from programmer's point of view, we don't need to have an else in here. Because if this condition, I'm going to stop when I found the item or when I reach the end. But this is going to stop when it reaches the end. So instead of having if and else, I'm going to come here and give the same space as the while, which means after the while is done, after everything in it is done, I'm going to print item is, or the key was not found. Try. Okay, so, and I'm going to return false. So why is there no if statement in here for this part? Well, because if we found the data that is equal to the key, I'm going to return true, I'm going to stop. And if I reach the end, this is the condition that is checking. If I reach the end and this condition is broken, that means I have went from this part here, here, then jumped here, and I still haven't found anything that can make this condition true, which means I never found my key, and thus I'm going to jump right after the while and print you didn't find it, return the false, because I reached this location in here. And we can actually, let me just change this really quickly. So we called it, what did we, okay, so TRA search, and we don't need that anymore. All I need to do is, let's search for number 5, and the key is found, rejoice, and true. And again, if we search for something like 88, which is not in our list, it's going to return the key was not found, try, with a false. As you see, so far linked lists have been very easy to work with. They are in reality much easier to work with than arrays or lists. They have so much more freedom whenever you're adding or deleting or searching for items. The thing is that you need to always start at the beginning and traverse your way through it. There is no direct access like with lists, and to be honest with you, I personally prefer linked list many folds or many times to lists and arrays. I think linked lists are much easier and much fun to work with. I would like to thank you so much for listening to everything that I've said so far, and this is going to conclude our simply linked list. I know that there are still so many questions still open. For instance, how can I search for something and not return true or false, but return the node itself? That is all going to be an assignment for you that you're going to finish hopefully on your own without copying and pasting from each other. And thank you so much for listening. I'm going to see you when we start with the doubly linked list. Thank you so much and goodbye.